During the last two sessions, what we were discussing is about the flowchart, the algorithm, the pseudocode, etc., etc. And towards the end of last session, we discussed about the flowchart and as well as the algorithm of bubble sort. So we know that bubble sort is done to sort a set of integers or a set of elements, array elements, in such a way that it can be sorted in the ascending order. That is, the lowest will come first and the largest will be at the end. That sort of an ascending order sorting is done. So in this case, what it actually does is the iterations. The first what we set is we set the iterations as 1. There are actually two different loops running that we will see in the details of this bubble sort, how it is being programmed, and then how it can be implemented in program. That sort of things we will understand better later. Later in your lab exercises it is there, so then we will study it more effectively, because currently you doesn't know about the loops and what are the incremental operations, etc., etc. But the algorithm is like this, that is we are picking up the largest one, by comparing two consecutive values, and then we are shifting that one towards the end. So that is the steps, and during the iteration one, a complete set of steps creates an iteration. So a number of iterations are done. The number of iterations will be one less than the total number of elements within that particular array, particular elements that is to be sorted. And in each time, during each iteration, there will be n-2, at least n-2 comparisons. Sorry, n-2. And the number of elements, how many number of elements are there? So that less than that one, that is 2 less than that one. So n-2 number of comparisons will also be done. So that the largest element will come towards the end, and the second largest element come just before it, likewise. So now we will see the pseudocode for this bubble sort. So this is the pseudocode for the bubble sort. When we are writing the pseudocode, what is important is that you don't have to give all the things in the sense whether you are declaring something or you are initiating something, that sort of things. That is iterations equal to 1, etc. That is that we are not giving it. So that sort of things will be done automatically, or it will be done or incorporated within this pseudocode, because the pseudocode incorporates some part of the programming language. So in this case, so this is a procedure bubble sort. This is the name for this particular program that we are discussing. So this is a procedure for bubble sort. That is, bubble sort is the algorithm that we are discussing. So procedure bubble sort. Then the input thing will be the array of items. So this is in this case, it is an array. An array is input into this bubble sort algorithm or bubble sort procedure. So then what we have to do is we have to find out the number of elements in the array. The number of elements in the array may not be given initially, but when we are implementing the C programs, in most of the cases, first we have to give the number of elements, so that we have to input the elements in the array. So what we have to give is we have to initially we have to give the number of elements. The user has to give how many number of elements are there in that particular array in our simple programs. So then the number of elements in the array is found out. In the C programs, it may be the user may be giving the input. Then what it does is it does two iterations or two loops. That is, one is here, 2 for loops is actually running. Looping is that is a cycle, that is a repetition of some specific operations. So that is a loop. In the previous cases, that is when we studied about the flowchart, we said one of the construct in the flowchart is a loop. So that loop is represented like this. That is here. This is actually a loop. This constitutes a loop. That is This is repeatedly conducted. So then this is that loop, that is 4 iterations 0 to n minus 1. Do something. This has to be done. This set of things have to be repeated using this particular iterations, or iterations 0 to n minus 1. That is from 0 to n minus 1 it has to do. So then we end 4. That is this n4. While we go for the n4, once this n4, this end4 is corresponding to this particular 4. So in each time this n4 is coming up, the iterations will be increased by 1. We don't have to increase it again, or it will increase on its own in C programming. So that is why we haven't written this iteration plus plus in this pseudocode. But in the case of the algorithm or the flowchart, you have to write it, because no component of programming is involved there. Only the basic concept is involved. So, but in the case of pseudocode, some components of the programming language is also involved. So that is why we are not writing this iterations plus plus somewhere here. So we can omit that particular iterations plus plus. Then again what happens is, so then the next loop is here. The second loop comes here. That is for j equal to 0 to n minus 2 do. So that is this loop. So this entire loop. This is the second loop in our flowchart. So that loop is coming up here. In the case of the pseudocode, that particular loop is coming up here. So this can be understood by connecting to one the output of one decision variable, or decision loop is connected to another decision variable. So that constitutes a part of another loop. So when two loops are coming up like this in a flowchart, it is represented as this type of loops. That is one loop inside the other loop in the case of a pseudocode. So then, so in the second loop, what happens is for j equal to 0 to n minus 2 do. Then inside this has to be done. This is being done like this. If array j is greater than array j plus 1. So here this is it. Array j is greater than array j plus 1. Then if it is greater, then we have to swap. That is, if this is greater, yes, we have to swap it. Then we have to go by end if. So if is ended, so end if is done. End 4. So again n4 came up, so j has to be increased by 1. Once we are coming out of this particular loop and we are going for this loop, j is automatically set to 0. When this particular line is run, this particular line is run from this line. That is, once this line is executed, and then from there, if we start this particular line, j will be starting as 0. J will be initialized to 0. If it is on the other way, that is, it is done from here, that is, it is run from here, then what happens is j will be the next value of j, that is, j will be incremented by 1. So that is the concept of for loop. So this loop is inside this particular loop. So then finally we end the procedure. Then we have to return the list. Actually, not the list, it should be array. We have to return the array. So that's it. Not end the procedure, return list, it is return array. We have to end the return the array. So that is the pseudocode for bubble sort. Then we go for some searching operation, that is a linear search, or also known as sequential search. The algorithm as well as pseudocode, and then flowchart for a sequential search or linear search. Sequential search is also known as linear search, that we will see the next. So the concept of search is like that. We have a number of integers in an array here. It is listed here. A number of values are listed here, and we have to find out a value, a specific value. Say in this case, say it is what we have to find out is 62. We have to find out 62 in this case. What is the best or the easiest way to find out whether 62 is present in this particular set of integers or set of values is we have to search it from the first location, whether the first location is equal to 62, second location is 62, etc. That sort of searching is to be done. And then once we find out the 62, if we find out the 62, we can return that 62 is found at this particular location. And once we reach at the end of this particular list, the list of items, at the end of the last item, and we check whether 62 is present, and if we doesn't find in any of the list, that is, if we have to find out 63, here we want to find out 63, say. So if we want to find out 63 in this case, if we are checking 4, not 63, 21, no. Likewise, we are checking every element here, and up to 10 we are reaching. Then further there are no elements. So when the last element is compared with the element to be found out, we say, and it is not found, and it is not matching with the any of the elements, then we say that this particular element is not found in the list. So this is the concept. So let's see an example of linear search. So in the case of C, when an array is declared or when a list is declared, the index is starting from 0. That is, 0 will be the index of the first item, and 1 will be the index of the second item. So if there are 11 is the index of the last item, that means there will be 12 different elements or 12 elements in the particular list. So here the index of the last item is 11, so there will be 12 elements in the item, in the list. So first what we do is we check whether this first value is the one that we wanted. No, it is not. 62 is not equal to 4. So what we do is we move this position one more. That is, the index is increased by 1. So the next index is searched. So the next index is 1. 0 plus 1 is 1. So the next index is searched. So it is 21. So it is again not equal to 62. So then we increase the index by 1, again by 1. So it is 1 is increased by 1, so it is 2. So then next 2, 62 is not equal to 36. So again it is not. So likewise we proceed. We next search for the index 3, that is the location 4, and we doesn't get 62 there. And when we reach the position 4, that is the index 4 and the fifth location, when we reach there, we get 62 equal to 62. So we have found a 62 in this case. Here we found the 62. Then we say that 62, the value 62 is found at location 5. It is not, or index 4 or location 5. The index is 4 and the location is 5, because the location count starts from 1, 2, 3. This is the first location, second location, third, fourth, and fifth. But the position is 0th position, first position, second position, third position, and fourth position, or the index. Index is also index 0, 1, 2, 3, and 4. So at the fourth index, we find out the 62, the value 62 we find out. Now the algorithm for the linear search is goes like this. We start. We have to first read the array A and the value X. The name of the array is A. So in this case, the name of the array is A, and the value that is to be found out is X. We say that the value that is to be found out is X. Now what we do is set I to 0, n to the number of elements in A. So n, the value n is set as the number of elements in A, and I is set to 0. Now if I is greater than or equal to n, so if I is greater than or equal to n, that means we have ended up searching all the items within that particular array or particular list. So then we go to the step 9. So the step 9 is print the element not found. So once we reach here, that is, if I is greater than or equal to n, we print that the element is not found. If the next step what we do is AI, that is, AI means A is the array, I is the index. So AI means, it means, so this like this. The locations are given like this, say 0, 1, 2, 3, etc. So if I is 0, this is A of 0. This is A of 0. If I equal to 1, this is A of 1. If I equal to 2, this is A of 2. So likewise goes. So if I equal to x, we search, our search starts from I equal to 0 to I equal to n. So if I equal to n minus 1, because when I becomes n, this goes to step 9. So A of I equal to 0 to n minus 1 we search. If A of I equal to x, then we go to step 8. So that is the value. If the value x value is found within this particular list, then we go to the step 8. Step 8 means it is print element x is found at the position I plus 1 and go to step 10. So the position is actually the location I plus 1 or the index I. If the index is to be represented, then it is I, or if the position or the location is to be represented, then it is I plus 1. Then set I equal to I to I plus 1. So we increase the step, increase the value I is incremented by 1. So that is we move to the next position in the array. So then again we go to the step 4. Then we check whether I is greater than or equal to n. Then go to step 9. So this procedure repeats. This entire procedure repeats multiple times till the value I becomes n, or we find out this condition A equal to x. So now let's see the flowchart for the linear search. So this is the flowchart for the linear search. So we start, read the array A, read the element to be searched x. So this step, read the array A and value x. So then we set I equal to 0, size n equal to size of A. So we set I equal to 0, n to the number of elements in A. We check I is greater than or equal to n. We check whether I is greater than or equal to n. If it is greater than or equal to n, then go to step 9. So that is, if it is yes, print element not found. Once print element not found is done, then we stop. Then if A equal to x, we search if I is not less than, greater than or equal to n, that is I is less than n. So in that case, A of x, A equal to x, we check whether A equal to x. If A equal to x, then we go to step 8, that is here. We go to step 8, that is yes, print element x found at position I plus 1. So this is being done. Once this is printed, again we stop, we go for the stop. Once this is no, that is if A is not equal to x, A is not equal to x, then we increment I by 1, that is I is set to I plus 1. So then again we go for the loop. So here there is only one loop is happening, only one loop, that is one for loop will be here. This is a for loop. So this is the flowchart for the linear search. Now we go for the pseudocode for the linear search. In the case of pseudocode, actually there is not much to write because there is only one loop available here, only for each item in the list. That is the procedure is procedure linear search. The linear search and list is to be input and value is also to be input. That is the two conditions. That is read A and read the x, that value. That is the list is A and list is A and value is x. So these two values are to be input into this procedure. And then for each item in the list, what we do is if we match the item, if match item equal to value, that is if the item is matched with respect to the value, then return the item's location. If item is equal to the value, that is item is matching with the value, then we have to return the item's location, end if. Else, if this doesn't match us, we don't have to give actually an end if, because an else if, else condition, because it will automatically, if this condition doesn't satisfies, if this particular condition doesn't satisfies, it automatically goes for the next item, because for each item in the list, we are checking for each item. And once it is found, the item that we are searching is found. Once we are found it, then we are exiting. We are returning the item's location. Otherwise, we will continue with this one, and at the end, we will end the procedure saying, here, if it is ending the procedure, then we may say that the item not found. That sort of message may also be given in the case of a pseudocode. That is actually not necessary also. And that is all about the linear search, the pseudocode for linear search. So we have seen the pseudocode algorithm and flowchart for two different algorithms. One is for bubble sort algorithm, and the other one for linear search algorithm. And that ends the module 1.